Hello everyone, I'm Nina and today I'm going to be presenting man is to person as woman is to location, measuring gender bias in name entity recognition poster. So in this work, we were studying name entity recognition or NER systems, which are systems that given a text or a sentence, they will identify the entities in the text and also return the type of the entities. In this particular work, we were interested in seeing how are these systems behaving differently across names coming from different genders. So as you can see in these examples, we have Charlotte is a person sentence, which name entity recognition system identifies Charlotte correctly as being an entity. However, its type is incorrectly tagged as a city. Or in another example, we have Olivia drinks water, in which Olivia is not recognized as an entity at all. So we were interested in seeing if we replace these female names by some male names coming from US Census data, are these name entity recognition systems gonna perform as poorly, or they are gonna be better in recognizing male names as opposed to female names as entities. So in order to evaluate NER systems, we created a benchmark dataset. This benchmark dataset contains some templated sentences which start from names coming from US Census data, followed by activities representing human-like activities. This is to force these names in these templated sentences to be tagged as person entities. Each template is designed to capture different types of biases, such as societal stereotyping bias in jobs or bias in family roles. There are some other templates which are more neutral, such as is a person, designed to only capture differences in female versus name entities or names. So to quantify bias in NER systems, we proposed different measures. Each of these measures was designed to um, capture different biases or errors, such as the entity not being tagged or recognized as an entity at all, or if it's being recognized, it's tagged as something else, or the hybrid case of both, as in not being tagged or being mistagged. We also had the weighted and unweighted cases, in which weighted cases are the ones that consider frequency of the name or how much popular the name is, so that if a name is more popular, we penalize the NER system more. And we also have the unweighted case, which doesn't consider this popularity into consideration. So to evaluate NER systems, we compared 5 different models: FLAIR, SPACY, small, medium, large, and CoreNLP. And we show that in all the cases, these models are doing poorly in recognizing female names as opposed to male names. And as you can see in these graphs, all the error bars for all the error types are higher for all the models in recognizing female names as opposed to male names. Here I show you some examples coming from the FLAIR model, in which you can see Charlotte is being mistagged as location, which is a really frequent name, or Sophia, Victoria, which are again so popular names, and being mistagged as location. However, for the male names, we can see that except Christian, the other names are not that popular names from the male entities or names. We also considered analyzing the data sets that these models were trained on. So we analyzed Connell and onto nodes, and we recognized that these data sets do not provide as versatile female names as they have for male names. And in reality, we need more coverage for female names. However, these data sets are not providing that coverage, because these data sets are coming from news sources, and already news sources are biased in not recognizing or providing female names. So here is our poster in which we provide more results. And this concludes my presentation of this poster. Thank you so much.